Hello everyone. My name is Daichi, and I will give you the lecture regarding the radiation and remediation activities. So, let's start today's lecture. Today's theme is Kinds of Radiation and Their Characteristics, Volume 2. Are you ready? Okay, last time we reviewed the kinds of radiation, and after the 3 kinds of radiation were elaborated, which need to be especially cared about after an environmental contamination occurs.
Correct. Specifically, 3 kinds of radiations, that is, alpha, beta and gamma ray were covered.
Right. Last time characteristics, as well as examples of application, of these radiations were touched upon. This time, as a continuous work from the previous lecture, we will go into more detail on characteristics of each radiation. Before going into the main topic of this lecture, let's review one thing just quickly. Do you remember the word ionization, hickory?
Well, actually, no. Sorry.
No worries. Let's review it together again. Previously I explained that the ionization is a phenomena in which a radiation with high energy pushes outward an orbital electron, which is a part of an atom of another substance. There are 2 kinds of ionization, that is, the direct and the indirect ionization. During the direct ionization, radiations ionize substances directly, and during the indirect ionization, radiations generate secondary electrons, which ionize other substances. Amongst the 3 kinds of radiation explained, alpha ray and beta ray have charge with themselves, and they travel by directly ionizing electrons which circulate around orbits of atoms. On the other hand, gamma ray is electromagnetic wave without charge. Therefore, it doesn't directly ionize, but indirectly ionizes other atoms, by generating secondary electrons, which generate as a result of mutual interaction.
I see. The approach of alpha and beta ray for ionization is different from that of gamma ray.
For the next, let us focus on the difference of mass and charge of each radiation. Given that mass of one beta particle is 1, mass of an alpha particle, which consists of 2 protons and 2 neutrons, reaches around 7,000. And charge of a beta particle is -1, or 1, because it is an electron, or a positive electron. An alpha particle has 2 protons, so its charge is 2. By the way, gamma ray has neither any mass nor charge, because it is electromagnetic wave. Okay, so, based on the difference of approach for ionization caused by each radiation, alpha ray, beta ray, and gamma ray, as well as the difference of mass and charge, let's look at the difference of penetrating power of each kind of radiation. First of all, alpha particle or alpha ray. As mentioned earlier, an alpha particle has much huger mass than a beta particle, although they the same charged particle beam. Therefore, an alpha particle moves more slowly, compared with a beta particle, which has almost the same level of energy. In addition, an alpha particle has larger charge than a beta particle, so once it is released, it travels straight, and interacts one after another, with other nearby atom cores or electrons. An alpha particle, however, interacts with many other atoms, in the vicinity of the release point. Therefore, it loses its energy soon, and it cannot travel so far. Moreover, what is important to be understood is that each alpha particle, or alpha ray has different energy, and the energy is determined by each kind of radionuclide, which emits the alpha ray. Specifically, each alpha nuclide emits single, or multiple alpha rays, with line spectrum, as shown in this figure. For example, Thorium-232 is natural radioactive material, and it emits alpha rays, with energy of around from 3.8 to 4.0 MeV. As another example, Radium-226, which was covered in another lecture, and once used as luminous paint for dial faces of watches, emits alpha rays, with energy of around from 4.6 to 4.8 MeV. Americium 241 is another example of element, which emits alpha rays. It is used in thickness meters, or smoke detector, and energy of alpha rays ranges from 5.4 to 5.5 megaelectronvolt. And there are a lot of other elements which emit alpha rays.
Oh, really? I thought that every single alpha ray has the same characteristics, including energy they have. It is so surprising to hear that each alpha ray has different level of energy. So, what about energy or penetration power of beta ray or gamma ray?
Well, today I went into detail about alpha ray, so let us finish for today, and for the next, beta ray and gamma ray will be elaborated in another lecture. So, let me wrap up my lecture by providing you the key points. Today, after we reviewed ionization just briefly, difference of approach for ionization was elaborated between three kinds of radiation, which were covered in the previous lecture. Specifically, I explained that alpha ray and beta ray ionize directly orbit electrons by themselves, and on the other hand, gamma ray ionizes indirectly, with secondary electron, which generates through interaction between gamma ray and other materials. Penetration power, as well as energy distribution of alpha ray, were also elaborated. When compared with beta ray or gamma ray, it travels more slowly and straight, due to its big mass or amount of charge, but it doesn't travel so far, because it is so reactive. In addition, taking thorium and other elements as examples, I explained that each alpha ray has its own specific energy, depending on elements emitting alpha rays, and its distribution is a single line spectrum, or multiple line spectra. Okay, today's lecture is now dismissed. See you next time. In this channel, the useful information regarding the radiation and remediation will be provided to you. If you like it, please subscribe to this channel, and do not forget to click the like button.